Rightio. So we're going to introduce the last concept that we haven't covered yet before our exam, and that's Newton's laws. Not a major concept at this point in time. I know that people love to reference Newton's laws, but they're all just about force and what happens when forces are applied. So the first one, and again, you intuitively know every single one of these. The first one, inertia. Has anyone heard the term inertia? Very good. Does anyone have an idea of what it means or where it's used? Jerry?
So like the motivation in your body.
Yeah, good. Yeah, can be used in that way. I like to think of inertia as an object's resistance to changes in motion. Cool? So if I apply a force, as much force as I can possibly apply on Nathan's calculator, will it move? Will it accelerate? What about if I try and do something to this wall or this board? Will it accelerate? Okay. What about if I had a 300 kilo bag of something, I don't know, toilet paper, gold mine in Australia right now. Had a 300 kilo, it's a big bag, all right? Big bag of toilet paper. I'm just putting it in my shopping trolley because the apocalypse is coming, right? If I try and push that trolley, is it easier to push or harder to push than an empty trolley? Very good. So, harder to get going. Okay, let's say I'm rolling along and I see a student. I know he's showing me the size of the fishing court in the weekend, and I see him at the end of the hall, and I let go of my shopping trolley. Okay, which shopping trolley is going to keep going further? The one full of toilet paper or the one full of, providing they're at the same speed? Let's say I've got them both to the same speed. I let it go. Which one's going to stop first? The empty one or the full one?
Full one.
The empty one's going to stop first.
Oh. Let's say, okay. New example. Same student, but I'm only half a metre away when I let go. Which one's going to send student further back? The heavy one. Okay, so which one's harder to stop? The heavy one. That's all about inertia.
Oh, so that's
Inertia depends on one thing and one thing only. Mass. Very good. Notice I didn't say weight, I said mass. Which brings me to my next question. How much do I weigh? I won't be offended. Every table can have a conversation now about how much I weigh. I'm going to give you 5 seconds. 3, 2, 1. Boys, what do we got? 70.
I don't know, 70.
70? 75?
400 kilos.
400 kilos? 72 and a half? 74?
76.4.
None of you are close.
Yeah,
Not one of you are close.
80, sir?
Was it 68? Surely not one.
Not one of you are close. I'm going to let you go back again. 5 seconds. Not one of you is close.
Yeah, sir.
3.
This is a trick question.
How much do I weigh? It's a simple question. How much do I weigh? All right, have another go. 60.
Let's go 76.
76?
86.
86.
91.6.
91.6. 79. 84.
Did 86.
69.
No,
Jerry,
86.
86. Jerry, your group's the closest, but you're still nowhere near it. Have another 5 seconds. Have another 5 seconds. They said 91. Have another 5 seconds.
Okay.
How much do I weigh?
No way.
I used to play in the front row.
96.
That's it.
96.
5, 4, 3, 2, 1. All right, go reverse order.
104.
104?
We didn't agree on that.
95?
93.
93? 107? 102? 98. 98? 110? Still, you're a little bit closer, but you're nowhere near it. 5 more seconds. 5 more seconds.
Is it more than what we've guessed?
I said, how much do I weigh? That's all I'm asking. How much do I weigh? It's not hard. 5 seconds. How much do I weigh?
I told you.
All right, what have you got, Jack?
I don't know, 200.
200.
We said 140.
140?
180.
180?
130 kilos.
130?
163.
160?
163.
170?
Changing depending where you are.
Does change, but how much do I weigh right now? How much do I weigh? I just want to know how much I weigh right now.
120.
120, rightio. We're closer, but we're still not there. Have another go. 5 seconds. I think the boys there were the closest. They said 160. They were the closest, I think. Or someone might have said 200. That might have been the closest. 200. 200 was the closest. All right. Let's go again.
225.
How much?
225.
225.
276.
190.
190.
300.
300.
212.
No way.
Huh?
9.8.
Probably the closest, but no. You're the furthest, but the closest all at the same time. How's that work? The boys said 9.8. They're the furthest, but the closest all at the same time. And Brielle.
1.8.
See, I've heard someone said my mass. Someone got my mass correct, but no one's got my weight correct. My mass is 75, but no one got my weight correct.
But no, sir, a scale doesn't weigh, doesn't measure your mass. A scale doesn't measure your total mass.
Scale doesn't give you newtons.
Hey, what, 75? So, I understand.
The mass doesn't change. 735 kilos.
No, close.
Sir, if
Yeah.
I say you weigh nothing on
Yep. I weigh nothing in space. I weigh something on the moon.
Sir,
Yep.
735.
I weigh 735 newtons. And that is where Newton's second law comes in, because my weight is my gravitational force. So when you jump on the scales, it converts your gravitational force into a unit for mass. So the amount of particles in my body, that's 75 kilos. Whether I'm on the moon or Earth or in space, that's 75 kilos. My weight changes. So you want to lose weight? Go to the moon. Want to lose mass? Get on a treadmill. See?
You said that one before.
I have said that one before, but you still took your 6 goes to get it with a massive hint.
Only that. We'll be here all day.
They'd have been here all day.
Oh, me and you.
I love that it was more plausible that I was 160 kilos and there was something else going on with the question. That's how we know we've got some really good scientific minds in the room.
Well, Aaron and I were thinking about that ages ago.
Okay, I did hear, I think Logan was on it pretty early too, but that's okay. The third law is every action has an equal and opposite reaction. Okay, that's a very, very common law, and I can prove it pretty simply. Yep.
Why, doctors ask you how much you weigh, but not your mass?
Because why do you think I asked that question? Why do you think? There's a reason why I ask how much do I weigh. To trick you. I'm trying to increase your recall by providing a situation where I've fooled you. Okay, so I'm converting when people say how much do you weigh, then what they mean is what's my mass. Cool? But when in a physics term, weight is talking about gravitational force.
If you said that to a doctor,
Yeah.
they'd be confused.
Yes. And they probably wouldn't get what I was giggling about.
Have you ever done that?
No. I wouldn't do that. Now, no, newtons, not kilos. Got to get your units right. Kilos is a unit for mass, newtons is for force. So I can prove Newton's third law. Okay, right now, does every person in this room have a mass?
Yes.
Does every person in this room experience a gravitational acceleration due to gravity?
Yes.
So every person in this room is putting a force onto that chair, correct?
Yes.
If I was to take that chair out, what would happen?
We'd fall.
You would fall, okay? What's that? So if you've got a force applying downwards,
You would go up through.
you'd keep going until a force applies upwards and equals it.
Yeah, with shock.
What's applying that force right now?
The chair.
The chair. The chair, correct? It's applying a force equal to your weight in the opposite direction. So right now, you're sitting on your chair. Here's you. Here's your chair. It's a good chair. I know what you're thinking. Why is this guy not teaching art? You're applying a force down on the ground. The chair is applying an equal force up. When I add those two together, what am I left with? Zero. So the net force must be zero. Why must it be zero?
Otherwise, you'd be going up and down.
If there was a force, do you have a mass?
Yes.
Yes.
So if there's a force and you've got a mass, there must be an acceleration, correct?
Yes.
So if you start accelerating sitting in your chair, start asking some questions about Newton's third law. But until that point in time, Newton's third law will apply.
Is that why like things will have like a weight limit on them?
Yeah, essentially that's there'll be a structural ability to hold on to it. When you kick a ball, okay, you're doing the same thing. You're applying a force onto a ball, it's applying the same force back. Kick a shot put or a table, and you'll know that law applies. Okay? Pretty confident. So they're the three laws. The main one as far as calculations are concerned is this one here. Okay, so F equals ma is the only calculation law that you'll be required to use. The others are purely descriptive laws. So why is this occurring? Does that make sense? So if I was to ask a question on inertia, I might ask a question of why is it harder to throw a shot put than it is to throw a tennis ball? Newton's first law. Law of inertia, it has a greater mass, therefore it has a greater resistance to change in motion. I might then say, when you are for third law, why do people who go shooting on the weekend, why do they come back with bruised shoulders? Recoil. Recoil is a equal and opposite reaction force. So the force applying on the bullet is equal to the force applying on your chest. Which sounds pretty crazy. But if you're firing a heavy bullet or a high caliber bullet, you're going to get more recoil, more bruising, if your technique's not very good. Cool? Sweet. They're the sort of ways those questions will be asked. Whereas I might ask you on an exam, how much do you weigh? And see what you get. Cool? I probably wouldn't ask how much do you weigh because I might get in trouble if I ask that question. But I might say Bob weighs 75, has a mass of 75 kilos. How much does Bob weigh?
Definitely gives me hints of the
Bob's a good runner.
Bob's good. Bob's
Bob's everything.
everything. All right, all good?